January and not June.
I wish it was June. If it was June, I would have be a Lord and Savior for the June paper in my back pocket. You can you could step away. Yeah, only if I had if I had the June paper, I'd be like a savior, I'd be like a god. But I don't think I'd give it to all, because I want to let to use all their brain and think.
Yeah,
Yeah,
but
that
still, I
was
do want to pass too. So
I think,
it kind of like to.
Nikolai, I think Ollie already have the capacity to pass. You don't need any handouts. We don't need any handouts here.
Oh, okay.
So, any volunteers?
Yeah, let me go one time, so
I see Romano on mute. Kelani, I cannot trust that you okay, I cannot worried about Romano.
yeah, I
I
feel
Let's
like
would,
stop
yeah.
yeah,
extra.
I would like to go with this one. These
I
kind of
remember.
questions is sometimes give me trouble, so I just want to make sure I have it done.
Yeah, give it a read.
The diagram below shows a running belt, E, F, G, H, I, J, E, that revolves around a running board on a treadmill. In the diagram, E, J, I, and H, G, F are semicircles with a diameter of 0.7 meters, and E, F, H, I is a rectangle. Calculate the length of the belt.
Before I do anything, I want to show you something. Do you actually know what a running belt is?
Kinda. Well, yeah.
That wouldn't suffice. I'm going to show you what it actually is. I mean, I'm sure you've seen it before. Watch. This is a running belt. For a
Yeah.
treadmill. Is there anybody
Yeah.
that didn't know that?
Oh yeah, I know what you're talking about too.
Watch. A
And then
big
just the thing that is moving on the treadmill.
Yep. I think a big part of maths is understanding what the heck you're doing. Because some people might read this question and they mightn't even know where's a running belt. Everybody in class, all you understand a running belt is like the belt on a treadmill, right?
Yes, sir.
Yeah.
Okay, good, good. And before we do anything, before we dive into this question, Romano, when we're talking about one revolution, enter would mean the time it would take for like the belt to start from one point and go around and reach back at that point.
Yeah.
You sure you understand what I'm saying?
Yeah. So one revolution is when like the treadmill it's going around and meeting back at the same point.
Yes, yes. So like, let me just say this was a marker point. This was a marker. Right? I put a piece of chalk here. I put a piece of
Yeah.
chalk on the treadmill over there. Put a piece of chalk. I am going to wait for this thing to revolve all the way around and come back here. That will be one revolution. You understand?
Yeah. Yeah.
All you understand what I'm saying, right? Here what I'm saying. Imagine the mark over here with a little piece of chalk. The running belt, it would go all the way around, and when it comes back, you would have traversed one revolution on the treadmill. Hope all you understand that concept.
Yes,
If you,
sir.
okay, good. So Romano, yeah. Did you understand everything the question said?
Yep.
Okay. Next thing. So Romano, before I read the question, E to F is 2.1 meters. What do you think I to H is?
2.1 meters.
Okay, cool. You're seeing two semicircles over here. Yeah or no?
Yeah.
Two semicircles make a what?
A circle.
Everybody okay with that, right? Two semicircles make a what, guys?
Yeah, circle.
Full circle, sir.
Good. Two semicircles make a full circle. And probably ones that like on the camera right now. You don't leave me feeling alone like this. Kelani, Gary, my
Yeah,
boy.
I come in there, sir.
Gary, you see Gary never sticking or big up Gary one time. Gary has now become part of the boys, you know what I mean? I had to change just to quadruple T's instead of triple T.
Quadruple T.
We had the same idea, Romano. Yeah. 2.1. Next thing. So everybody understands that two semicircles would make one full circle. Yeah?
Yes, sir.
Okay, next thing. Romano, when you look at this over here, is that the radius or the diameter?
Diameter
Right. So if you wanted to find the radius, what the radius will be?
will be half of 0.7, which
Which
is
is
0.35.
right. Like, give me a second. I draw this, like I recreate this paper. So like this is actually a drawing. Yeah. Um yeah, Romano. So like this is 0.35, you agree?
Yeah.
All right. And in the first part, they want us to calculate the length of the belt. The length of the belt. So Romano, if you want to find the length of the belt starting from this point, you go 2.1 over here, 2.1 again over here, and you return back to the original point. Do you understand that, Romano?
Right. Yes, sir.
Yeah, sure.
Yeah.
So length of belt is just going to be equal. So how much 2.1s we have?
2.
2. So that's going to be 2 by what?
2
What's
by
she man in the
2.1.
towel? What's she man in the towel? Boom, bukla. Hey.
Don't know, sir. Don't know. Don't know.
Man looking like a Maharaja. Like them Indian people with the turban, with the turban. Hey,
Yeah.
next thing my channel get cancelled. They say I being racist and thing, boy. Hey. Yeah, so that'll be 2 by 2.1. And we need to cater for the two semicircles. Now, Romano, like I said, we literally have two semicircles. So if you combine the two semicircles, it'll form a what?
A circle.
And so if you want to find the length, around, so here what I was saying, right, Romano? Please tell
Right.
me if you're confused. So like this will be E, also F, G,
Right.
H, I. Right. So I really hope you're not confused. So like what? All I did was, Romano, I took this,
I just put it together.
I just put it together. That's all I do. So, Romano, if I want to find the distance around, that would just be one full circumference, would it not?
Yeah.
Yeah. So that's just going to be 2 by 2.1. And what is the formula for circumference of a circle?
2 pi r.
Right. Or you could just say pi d, but I prefer 2 pi r. And most people go understand why. Where's the area of a circle, guys? And most people, where's the area of a circle? Well, everybody should know this,
R squared.
right? If I find d, dr, what that will be? And most people.
2 pi r.
Yeah. That is why I prefer 2 pi r, because it's the first derivative of area. When you differentiate area, you find like a lesser dimension. Because watch, it's area over radius. Area is squared, radius is just, see, you're like essentially getting rid of one dimension. Yeah, but anyways, circumference is 2 pi r, right, Romano? And we know the
Right.
radius is 0.35, yeah?
Right.
So all we had to do, right, is gonna be 2 by 2.1 plus 2, and pi is what? Where's pi?
22/7.
Yeah, multiplied by,
0.35.
that is it. That is it, my boy. Was that hard? Tell me, Romano, was that hard?
That was easy.
That was very easy. So what would that be equal to?
Just
I'm calculating it too. I got to literally do it today. When we do them papers from like 90s. Are they gonna lose some here? Are they think
I don't want to lose my hair. Take
So
long,
if
but
you, if you do
good.
it from the 90s, you'll be qualified to do any kind of measurement question.
for sure, for sure. For sure. Alright, I'll get 6.4.
Yes,
So,
sir.
And it wouldn't be meter squared, eh? Length. So what did we just find for, guys? What we found for?
Length.
length of
You
the
see,
belt.
That's what we
Also,
just
also could have been
Right.
known as the perimeter.
said that again.
Also could be known as the perimeter.
Exactly. That's what the perimeter is, just the distance around
Yeah.
that. So is there anybody confused at all? I've been working for part one.
So
So,
you just find the you just had to take into consideration the full circle and plus the both lengths, which
That's
is
all.
the 2.1 meters.
Yep.
So I have a question.
Yeah, Gary. Talk to me.
Why we multiply 2 by 2.1 again?
All right. How much? Okay, so like look at this, right? We have a 2.1 here. So Gary, imagine you traversing around the shape, right? You'll travel 2.1 here, you'll travel some distance here, and then you'll travel back 2.1 here. How much times you travel 2.1 meters, Gary?
Twice.
Exactly. So you could say 2.1 plus 2.1, or you could say 2.1 by 2. You understand?
Yes, sir.
Everybody okay with that?
Yes, sir.
All right, bet.
Yes, sir.
Ladies, I know the ladies is be real quiet. Ladies, are you okay? Alexia,
Yes,
Alexia, Akira,
Yeah.
Ria, Christian. Christian is not a lady, but I want to hear it. Samir, Sky,
I understand, sir. I understand.
Kaylee, Regina, Krista, Joshua, Adetola. Are any of you guys confused?
No, sir.
That's I good for now.
Right. I tell you now, they're gonna hit me after this, you know. After today, wait, I'm surely why they go hit me. Look at these questions.
no, sir, nobody gonna need this. Nobody gonna need this.
Once we pass
You
maths,
learning
nobody
this
got
vibe,
it
it's a
here.
vibe.
Sir,
Are
you
they,
gotta learn the process, sir.
are
If
they
you
see
gotta
this?
go through the difficulty, sir.
Well, yeah, for sure, but let's see in this.
Right.
Yeah,
Got that
seen
much
it.
words.
Have more words than
Watch this
numbers.
now. Watch that.
Yo.
Sir, so
We're gonna be
That is expansion.
Wait now, so wait now.
Like,
They were my grandmother was doing.
yeah, yeah. I hope they have respect for all their elders because they was doing much harder things than all that. Watch this, watch this, watch this.
They were alpha coming in the mix, boy.
Yeah, and that's what we're gonna be doing today. No baby thing. Come on, guys. This is math vibes, not baby vibes.
actually, sir, it says a lot from in the past till now, sir.
Say that again.
It says a
No
lot
wonder my
about the
grandma
past
trip
and
out.
now.
Shoot.
Exactly, because like I feel like they're making the exams progressively easier. Genuinely. It goes to show that I feel like I worried about the future population and like being real. I feel like eventually
Yeah.
we're gonna reach a point where we just like well, we can't think for ourselves at all. We're gonna reach that point eventually.
And what is 6 plus 1 and all kind of stuff.
7, 8, Nikolai.
nah.
Yeah.
Seven.
Alicia Nikolai
Baba,
doesn't moving. Alicia Nikolai
see?
doesn't moving. Hey,
Baba,
Nikolai.
Nikolai, you call that one.
Sir, I
They
never
never
said,
catch me in them thing yet.
sir, I never say nothing, you know. Or I just say
It was
6
inferred. It was inferred. But anyways, let me go on the maths, right? So Romano, read the second part for me.
Glenda uses the equipment to exercise 4 times a week and runs at 9 kilometers per hour for 20 minutes each time. Calculate the number of complete revolutions the running belt makes in 1 week during Glenda's exercise routine. Assume that the running belt moves at the same speed as Glenda.
Okay. So did that question intimidate you?
Not too much.
For a second, it looked like it's gone to the speed phase, right?
Not too much.
All right, all right. Let me understand what happening, right? So first of all, Romano, how much times does she exercise in a week?
4 times.
Right, 4 times. And when she does exercise, what speed does she run at?
9 kilometers per hour for 20 minutes.
So I'm gonna show you how to
Each.
think. I'm gonna show you how to think independent of the formulas. Yeah, you don't have to know any formulas for this. Romano, when I say 9 kilometers per hour, logically, what does that mean? When I say 9 kilometers per hour,
You're running 9 kilometers every hour.
exactly. So in 1 hour, you're running how much?
9 kilometers.
Cool. And every time she exercises for what duration?
For 20 minutes.
Right. So the time is equal to 20 minutes. Now hear this, right? Romano. The distance in kilometers and time is in hours. So that 20 minutes will have to be converted to what?
Was
Right. 20 minutes is what? Is how much hours? So to convert minutes to hours, you divide by what?
60.
Right? You divide by 60.
0.3.
Now leave it as a fraction.
Okay.
Because if you go to round it off, it wouldn't be exact. Leave it like this. So, okay,
Yeah.
is there anybody confused as to how I broke down the information? She exercises 4 times a week. I write that down. But what speed does she exercise at? 9 kilometers per hour. What does that mean in English? It means that every 1 hour, she travels 9 kilometers. I feel like, did I make a mistake in this? Like when I was copying down the question? Give me a second. Was it kilometers or was it meters? Let me just check something real quick.
So it was kilometers.
Oh, so I didn't make a mistake when I was translating it.
I think it was in kilometers, but then we had to convert it to meters.
Now you could leave it like you could leave it as kilometers. Be fine.
Okay.
When you finish in the end, you could probably convert it. But yeah, let me continue. Yeah, because I got type up the paper and I feel like I make some mistakes. But anyways, let me continue, right, Romano?
Right.
So every time she exercised for how long?
For
How much
20
hours?
minutes.
Right, which is yeah,
1/3.
1/3 of an hour, right? And Romano, we know that in every 1 hour, she travels how much kilometers? Tell me, Romano, every 1 hour she travels how much kilometers? Romano?
Yeah.
Every 1
Right,
hour.
9 kilometers.
Good. Happy that you understand that. If for instance, I told you she ran for 2 hours, how much distance would she have covered?
18 kilometers.
So if she ran for a third hours, how are you doing now?
You multiply 9 by a third.
That is all. That is all. And again, I'm trying to teach all you how to think independently of the formulas. I'll show you guys how to do it with the formulas at the end. Yeah, so Romano, in a third of an hour, she'd have covered how much kilometers?
3.
Okay, so does everybody understand how I found that she traveled 3 kilometers? Yes or no? If anybody is confused, tell me.
Yeah, so 9 divided by 3.
Right. Is there anybody confused as to how I figured out that she travels 3 kilometers in one go?
No, sir.
Ladies, all you understand what I do so far?
Yes, sir.
Okay. Yeah, so Romano, what did we do so far, right, Romano? Well, we found the distance she covers in one session, but for a week, how much time does she exercise?
Will you repeat?
Romano, we found the distance she travels in one sitting, but how much time does she exercise in 1 week?
4 times.
So the total distance that she covers is really what?
Okay. So 3 by 4.
Yeah, 3 by 4. And if you're confused by that, remember this would be for one time. You understand, Romano?
Yeah,
All right. So in 1 week, she would travel how much kilometers?
12.
Good. And what would one full revolution? Okay. If again, remember what she with the chalk, right? If you mark the chalk over here, into one full revolution for the belt would be what? What do you think one full revolution for the belt would be? How much distance? What distance?
6.4 meters.
Exactly. Exactly. So if you want to find the number of revolutions, that is literally what's it? Revolutions. That's just gonna be the 12 kilometers, which we know is 12,000 divided by 6.4 meters. And what is 12,000 divided by 6.4?
1,875
Are you okay with this?
meters.
Whoa, whoa, whoa. Romano, not meters, eh? They're asking us for the number of revolutions.
Oh,
I wouldn't say number of revolutions as meters.
yeah.
I just asking how much times the belt would I move like go from one point. I come back to
Yeah,
that.
how much times? Yeah, how much times if
So let me know if I fully understand the question.
Yes.
The walkthrough was nice, sir.
You understand it, Kalani?
Yeah, the walkthrough was good.
Now that's one way you could think about it. If you want, you could also use the formulas for speed and distance and time. So somebody remind me, what's the formula for speed?
Distance over time, sir.
Distance over time, sir. Excuse, sir.
Yeah, Nikolai?
I've wrote down your way of working on the question, but I also did my way of doing it. But I realized that I've gotten a different answer to yours.
What do you get for your answer?
Well, I just used the 12 divided by 6.4, and I
Anybody
got
wait,
1.2.
wait. Anybody could tell Nikolai why that illegal?
Because 12 is kilometers and 6.4 is in meters.
Yeah.
Okay.
Nikolai, what distance did she travel? Did she travel 12 meters or 12 kilometers?
Meters.
Wait, let me check back something. Because I had copied out, I had like two back this paper, right? Let me check the original paper to make sure I didn't make any mistakes. What the original paper they buddy?
Sir, I
Yeah.
think I went to the paper already, but as to do that, I didn't really I did not do that. I did not do the revolutions question because we didn't cover it in school.
Okay. I'll go it over again, but it's not hard. I just not finding in 2026 paper. The original one. Where are they, boy? Hope this is it.
I find mine.
Where the hell are they, boy? It can't be that hard to find. Okay, I'll find them. Did I make any mistakes? Nope, I didn't make any mistakes.
No,
Nah. So Nikolai, I didn't make any mistakes. So Nikolai, let me try to explain it back to you, right? Alright, so Nikolai, what is the distance around the belt?
Meters.
6.4 meters. Meters. But the distance she traveled, was it in kilometers or was it in meters?
Kilometers.
Exactly. So you need to convert kilometers to what?
Meters.
Right. You understand?
Yes, sir.
Everybody okay with that?
You must
Yes,
have
sir.
one too.
Now, if you had used this, well, to make distance the subject of the formula, you'd have had to multiply both sides by what?
Speed and time.
Not
Speed and
speed
time.
and time. You'd have just multiply both sides by time.
Oh, I mean like, oh yeah, well, speed is, sorry, distance is speed multiplied by time.
Yeah? So, speed by time gives you what?
Distance.
I mean, we essentially figured that out without any formulas, so that was good. I mean, we literally figured it out without any formulas, right? If all I could understand this hack, hey, this hack is so goated in chemistry. Like when I was doing chemistry, this is what I used to do. Watch, 9 kilometers per hour. Ladies, if I say 9 kilometers per hour, how much distance does she travel in an hour? Any only ladies could tell me? If it's 9 kilometers per hour, how much distance
9
do you
kilometers.
exactly? So if she travel at 2 hour, wouldn't that be at 2 9? 3 kilometers? That's real easy, right? Don't know if you understand that.
Yes, sir.
Yes, sir.
Are you sure? All we do is
Yes,
multiply, you know. Okay. And well, you could do it like this as well. Distance is just speed by time. And well, if you do it like this, you get the same answer. Watch, because the speed was 9 kilometers per hour. And well, the time was a third. 9 by a third is just 3 kilometers. Yeah, Nikolai, I see you raise your hand. Talk to me.
I realized that you said that you could have used this method for using chemistry, right? When you're doing the chemistry crash courses, would you be able to just
Hey,
show us
chemistry,
that way out?
chemistry crash courses. What? You putting words in my mouth?
Oh, no,
Chemistry
no, 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 no.
crash courses.
I can remember
Not
clearly
crash
you
course,
said
but
that
deep lives.
to Nikolai.
Okay, I will try to do one past paper. One past paper. One past paper. But try to do one past paper. Probably 2026 or something.
Yes, I have the answers for that already, so I could just help you if necessary.
So you
We
want
say
try?
real do like chemistry.
I do real good in chemistry too, you know. I just don't like chemistry.
No,
Like
but well, like, I know how from the answers that I got from the 2026, I could have understood that. But if I was supposed to do it by myself in the exam, but in a different year and a different question, I may or may not figure it out.
I see.
And I saw that you used this method and you said you could use it in chemistry as well.
Yeah, like okay. Anytime I see molar mass, right? Like okay, let's just say I say 0.6 moles per gram, right, Nikolai? As molar mass, I think. But like, long story short, what does this mean, Nikolai? This means that in 1 gram you have how much moles?
Huh?
Okay, wait, I'll go to
Wait.
I'll go to
1 gram is 0.6.
yeah, 1 gram is 0.6 mole. Yeah, you understand that?
Yes, sir.
So if they ask me how much moles it would have, how much 1 mole would be, well, to find for 1 mole, I would just divide both sides by 0.6 to find for 1 mole. So 1 mole would just be 1 over 0.6 grams. You could use math so much times in chemistry, it's crazy. This is simple trick over here. Just look at the units.
So it's just the method how they use it compared to what you're telling me here now. It makes it look confusing.
But when I was doing chemistry, that's how Miss Sangita would have shown it. Miss Sangita is a goat, by the way. She's real good. Best chem teacher. Yeah.
So then now show me no, listen, sir. We went the difficult long way and you had to put in statements, all kinds of stuff.
Hey boy. Oh, and if it's too late to check Miss Angita, boy, I go message her and ask if she do anything. Some of my students want help. Tell you. Alright.
So you do IT too?
No, I don't do IT. But I technically could teach IT. I mean, I do no bachelor's in electrical and computer engineering. Should be able to teach IT, CSEC IT.
So the teacher wants a program.
I hate programming, boy. I hate that. And like, you know about vibe coding? You know about vibe coding? Like where AI does most of the coding for you? Anybody know about
Oh
that?
yeah,
Nah, son.
we actually do
No.
that in school.
Yeah, I just vibe code. I don't really like to code. I hate to code. That's my ops.
So you see
But
these problem solving situations you start to do where you start
yeah.
to write pseudocode and the tables and things, that's what troubling me right now.
Yeah, that used to give me problems too, but actually getting through it these days.
Okay, how to do UML class diagrams or not? You gotta do diagrams?
Yeah, for the pseudocode.
Yeah, like
Yeah, the starters,
Oh
like a
yeah. So we
oval,
start to
a
do
circle, and yeah.
and the rectangle and the
Well, that
cube.
shape is
What
not really
real
a
hard
thing in
is the flow?
pseudocode,
Well, not
but
hard, but what annoying is like the flow charts.
yeah, flowcharts.
Nah, flowchart's easy. Is the pseudocode. I just forget the pseudocode fast.
I hate programming, bro. I hate programming. I like the problem solving, but not the code. I don't like to remember stuff. I just figure things out.
Yeah, like Python and thing.
I just don't like programming in general. So I'm gonna move on. Um, Joshua, let me know if you want me to run it back again.
Huh?
You want me to run through this again, or you okay?
Understand.
Bet. Now I'll pick all your poison, right? Pick all your poison well. Um, hmm, hmm. What do you want to do, boy?
Anyone fine by me?
Yeah, we did hardest one and see if we could do it.
I don't think Ollie could do it. Let's try this one, huh?
As soon as he stopped there, I realized it's that question. Like I wasn't studying the rectangle, weird looking shape. I knew so I was going to choose this one.
Yeah.
Ollie, thing easy, boy. All of this easy. Hey, everything in maths is look hard. It's look hard, but like not that hard.
So we're going back into the days of Einstein here, you know, so
Nah.
Well, who wanna help more with this question?
I don't mind.
All right. Well, Nikolai, give it a read.
In this question, take I to be 3.142. Diagram 1 shows a cylindrical tank of diameter 60 centimeters and length 80 centimeters. The tank is partly filled with water and placed with its curved surface on a horizontal floor. Diagram 2 shows a circular end of the cylinder. O is the center of the circle and D is vertically below O. The chord AB represents the level of the water surface and angle AOB is 120 degrees.
Well, you see how intense these questions are? Like they bring in multiple things into one
Let's
go.
see the number now, boy.
That's it.
We side to see the number in the Ramano.
No, sir. This
What?
actually looking nice, sir.
Yeah, it's actually easy. Continue. So the first one.
Calculate the length of the arc ADB. My bad.
All right. Well, let me start on. So first things first. They're telling us that the cylindrical tank has a diameter of 60 centimeters. So could everybody agree that this would be 60, this would be 60, this would be 60? All are we agree on now?
Yes, sir.
Okay.
Yep.
So like if it has a if it has a diameter, right, of 60. Wait, so let me just check something. Let's see this. Let's see how they say the chord AB. Let's see how they say the chord AB.
Yes, sir.
If they say chord AB, can you assume AB is a diameter? It is said chord AB.
Sir. No, sir.
No. Very, very sneaky. You have to be careful. But wait, you gotta be real careful here. 1 second. So, has a length of 80 centimeters. Did they say it was semi-filled?
No, they never
It
said
is.
semi-filled. They only said partly filled with water, so we can't assume it's
Can't
semi.
assume that. Cannot assume that. Okay, no, but now this question easy. This question easy, right? So Nikolai, first things first, and anybody in class who thinking that AB is a diameter, no, no. I mean, this is the center. Watch. They said O is the center of the circle. Does AB pass through the center? Oh,
No, sir.
No.
No.
no. So you can't make any weird assumptions. Now, if here to here is the diameter, why it's so big? If here to here is the diameter, then what would the radius be?
Half of the diameter, which is 30. No, we can't assume that neither, so it's just 30.
No, we could assume this, Nikolai, because they literally told us that the diameter is 60 centimeters. So we know that this is the diameter. They told us that. And so half of the diameter would give you the radius. Do you understand?
Yes, sir.
Okay. Next question, guys. What do you call a point from the center of the circle to the circumference?
2 radii. Well, a radii.
Everybody know that? That a point from the center to a point at the circumference is the radii? Yeah or no?
Yes, sir.
Okay. And we know that the radii is how much centimeters?
30.
30.
Did I confuse anybody?
Yes, sir.
Yeah.
All right. And that is the angle for the arc here.
Yes, sir.
And they want me to find the length of the arc ADB. No problem. So in the first question, this is what they want me to figure out. Now, could anybody remind me what an arc is?
The arc
The
is right.
outer, yeah, on the outside, on the edge.
No, that's the. Oh no, yeah. That's correct. That's correct. So somewhere they're probably asking us for the area of the sector. Yeah. Anyways,
But asked if we were supposed to do that too. And then we
Ah.
just find the area of the triangle and then minus it from the 2 to find that side. And then so we could use that. Then we find the volume of the cylinder and then find the volume using these measurements from the shaded region and just minus it. Or no?
you could do something like no, Nikolai. Nikolai, you're thinking properly. Because Nikolai, if you know what this area is here, you could find this volume by multiplying it by its height, which is 80. So that was really good thinking. I'm not sure if you're thinking along those lines. Are you?
Yes, sir.
Okay, good. So, can anybody remind me what the formula for length of an arc is?
Wasn't
Angle over 360 by 2 pi.
Right. So remember, arc. Okay, the arc is just a fraction of the circumference. Everybody know that?
yes, sir.
Right.
And a full circle is how much degrees?
360 degrees.
Good, 360 degrees. And like I said, it's piece of the whole circumference. So you'll say 2 pi r.
Yes, sir.
Now our angle here is 120. So it's going to be 120 all over 360 multiplied by 2 by, and they said pi is 3.142. And what was the radius?
30, sir.
30, sir.
Yeah, so plug that into your calculator and let me know what you guys are getting. I like these questions, boy. These old
I got
questions.
I got 62.84.
We'll verify that.
Yes, sir, that's the answer.
So bringing back nostalgia.
Hey, oh God, I know that old, like, hey, Romano.
I like that one, man. I like that one. But sir, in alliance, sir.
I write exams in 2019. Well,
I
Oh.
thought 2020.
either 2019 or 2020. I don't remember.
So can you solve the 2019 paper back to front?
Yeah. What? What kind of question is that? What kind of question,
What kind of simple question is
Well,
that?
what kind of question is that? Yes.
Well, I think so. And you find like from then to know the real water on the questions.
Of course. Like the questions are so easy. Unless you
I feel like
just
in the future years to come, sir, in the
yeah.
future years to come, a whole math paper could be solved just using the Casio, you know.
Yeah. Kelani, compare this to this. Yeah, everybody gets 62.84 centimeters.
Yes,
Yeah.
sir.
Let me run through that back one more time, right? So everybody, when you read the question, can you assume that AB is a diameter?
No.
no.
No, does it pass through the center? Like, okay, if you look at this diagram, does AB pass through the center?
No, sir.
No.
No, so please don't make any weird assumptions. However, we know that the diameter is 60. This is 60. And so if the diameter is 60, what would the radius be?
30.
30.
Good. In the first question, they wanted us to find the length of arc ADB, which is piece of the circumference on the outside. But how much? Well, you can see that this sector over here has an angle of 120 degrees. So this is actually just what fraction of the whole circle? What fraction of the whole circle that is?
120
360.
over 360.
Which is a third, right? Everybody with more now.
Yes, sir.
Yeah.
Yes, sir.
And we
Wait, could
understand
you repeat that?
no problem. So how much degrees does it have in our full circle?
306.
Right. And this sector over here has an angle of what?
120.
Right. So that would be a third of the whole circle because it's 120 over 360. You understand?
Yes, it's making sense now.
Good. And like I'm saying, Krista, the length of an arc is just piece of the whole circumference. It's a fraction of the whole circumference. That makes sense?
Yes, sir.
Good. So this sector over here is a third of the whole circle. So the length of the arc would just be that fraction multiplied by the whole circumference. Because again, arc is just piece of the circumference. So circumference is 2 pi r, but this is a third of the whole circumference. So that's why I say 120 over 360 by 2 pi r. So the length of the arc ADV is 62.84. I feel like I'll understand that.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, let me move on to part B now. The area of the triangle OAB. I would have taught you guys this formula. I remember a formula that I would have saved for included angles to find area of a triangle with an included angle. Yeah or no?
Yes.
AB sine A still? A half AB sine, well, a half AB sine C. Yeah. It really depends on what the two included sides are. It depends. So if this is, watch. Let me go it over one more time. The reason why I'm saying this, right? In the next question, they want us to find the area of OAB. Are you seeing that, right? OAB.
Yes, sir.
When you
Yes,
look
sir.
at OAB, what kind of angle they have inside OAB?
120 degrees.
Okay, no, what kind of angle is like a
Oh,
what?
included on.
What kind of angle? Anytime you have an angle between two known sides, what kind of angle they call that?
The included.
Angle, sir. Good. Anytime you are dealing with an included angle, and you're trying to find area of the triangle, use this formula. So this will be common B, this will be capital A, what's in? Common A, common C, cool. And to find the area would be a half. Well, in this case, it will be a half BC sine the included angle. So what's saying is if you have a triangle with an included angle, it is going to be a half by a known side. What's saying? It should really be by the adjacent side. And adjacent just means right next to the angle, right? So adjacent side by the other adjacent side sine the included angle. Okay, so please, guys, remember this. And you use this formula anytime you have a what? Somebody tell me. You use this
Then
formula.
included angle.
Right.
Included angle.
Whenever you're trying to find the area of a triangle, that's also an included angle.
Yes. Ladies, are they understand that?
Yes, sir.
Ladies. All right. So, ladies, tell me, could I use that formula in this scenario over here? So, one of the ladies, tell me, could I use that formula to find the area for this triangle?
No.
Any of the other ladies wanna answer? I just say Keely. Alexia, do you think we could use our formula for included angle to find the area for this? Tell me, Alexia, are you seeing any included angles for that? Can I hear Alexia, Regina, Sky, Ria, Akira, are you guys seeing included angles here? Any included angle?
No, sir.
Yes, sir.
No, see, you can't use it. You can't use it. What about now? Wait, what about if I move it over here? Bro, good notes. Hey,
Oh, yeah.
hey. Right. Yeah, could we do it now? Could we use the included angle formula now?
Yes, sir.
Cool. Random question. If I wanted to find the length for this side, what would I use?
The cosine rule.
Yes,
Don't
bro.
know. You don't know.
I'll probably fed up on me saying that in them
You want to know
videos.
how to in life? I look like the smartest kid, but
Say that again?
I say if I was to get interviewed by what you know now, and he starts me that, I'll get it correct.
Yeah, for sure. I'm waiting for him to interview me. Hit him with some
Nah, but
quick maths.
he not even in the country right now.
Yeah, he in New York. Or like,
Yeah, he just going places.
man, like speed.
I hear speed collapsed today.
Yeah, he
Serious?
collapsed, right? Yeah, he
Yeah.
collapsed in St. Martin.
He failed. He was on stream for 14 hours and went to 5 different countries and couldn't make.
I
Boy.
know speed need rest, so.
Yeah, for sure.
Yeah.
That man had real energy, boy.
So clearly you are better than speed because you just stay for like 24 hours, 48 hours and that kind of thing.
And do maths, eh? Yeah, for sure.
But what matters is that Speed said that so far the best food he eats is from Trinidad.
Hey,
Yeah, boy.
everywhere he go, he just asking for doubles though. The man asking
Yeah.
for.
He missing
Yes, sir.
And Bacon Shack.
Oh yeah, no, what's real funny is he had the mic on and he went to the toilet and it was.
Yeah, that was the best.
And why he kissed the man, boy? Why did he kiss? Hey, let's see the clip where he like give the guy.
Yeah.
He do that because he speed up his fans, so that was going on there.
Yeah, well that was nice. That was kind of heartwarming. So let me continue, right? So guys, looking at this triangle over here, could you guys tell me which one is the included angle? Is it A, O, or B?
Also,
Everybody agree that the included angle is O?
Yes, sir.
Yes, sir.
If this is angle A, what would I call this length over here?
Come on here.
If this is angle B, comma B.
B.
So what would the area formula for this look like? It'd be a half.
B multiplied by A sine of O.
Is there anybody extremely confused?
Nope.
No, sir.
That's right. Fully understand, sir.
So A is 30 and B is 30 and the angle is what? What's the angle?
120 degrees.
Is 120.
Plug that into your calculator and let me know where you get. So like when all your parents and
89.71, but I could be wrong.
No, it's correct. It's 389.71.
okay. So when all your parents telling all you that, they'll they do some more advanced stuff or they could see that they did, Or yeah, they give the people some credits. Right?
Yes, I get 39.7. What? And
And
they
it,
say three significant, and they say three
yes,
significant figures.
three significant figures.
Oh,
Yeah, well, that's what they want nowadays, right? So when we're doing all of this, it's supposed to be the three significant figures. So this would be 62.8. That's what they want nowadays. They want three significant figures. They literally say that in the instructions. So this the three significant figures would be what?
390.
390, sir.
I don't like three significant figures because they're kind of inaccurate, to be honest. Two decimal places is a lot better. Yeah.
Yes, sir. But it's how they want this stuff now, so you gotta go with it.
Okay, so we answered 2 out of the 4 questions. Is there anybody that did not understand the area? How I did the area?
I now realize maths is just look hard, sir.
It just look hard. Ladies, do you guys understand that anytime you see a triangle with an included angle, you're going to use this formula? A half by the adjacent side sine the included angle. I hear any guys, man. I hear any ladies, and I'm kind of concerned. Any ladies representing? Want to represent the ladies? I don't hear any ladies.
Yes, sir, I understand.
Okay. Sky.
Say your favorite child, Sky.
I don't know how.
I see.
Sky, point a camera and participate, be part of it.
So, no. Mm-mm.
Sky, I want to see your
Cool.
passports,
I hear.
All right, let
So
me
I
do.
want to see that too.
Well, you had to put any work, right? Nikolai, read part, see for me.
The area of the segment ADB, the shaded part of diagram 2. Is the same
Alright.
thing I'm talking about?
Yeah.
A minus
So-
the triangle.
So if you want to find this area over here, wouldn't you have to find the area of this entire thing and then take away this area from it?
Yes, sir.
Yes, sir, could I composite shapes?
Yeah. So you would take away the area of the triangle OAB from the whole sector. I really hope all is seeing that, because I feel like a good bit of you guys not seeing that or not seeing anything.
Yes, sir.
Like I say, I just stay up at night, like this is like genuinely, I just can't sleep, like when I'm all like confused. It's God.
Yeah, boy.
So I'd have some days where I'll just be sleeping and I'd be just dreaming myself doing the maths, sir. And I just feel like I really don't sleep.
You have any maths dream?
I tell you, that's my son. What I expect.
Dreaming about maths? Sir, if I dream about maths, I will have a nightmare.
Maths is the best. Maths is the best.
No. When you're dreaming about the maths and you see yourself figuring it out, that's not a nightmare way. You go come to a reality.
Exactly. It was one of them lives.
It'd be real funny if
If like what?
if you dream that you're doing a whole maths paper and then for CXC the same exact question, just come on in exactly the answers, but
Then you
And that
would be
would
in
never
time
happen, bro.
trouble.
Imagine. No,
That
no,
would never
no.
happen, bro.
Don't say it will never happen. You don't know.
I mean, paper one, yeah, but
Imagine the night before C-Sec, you dream that.
Okay, okay, let me lock in, guys. Let me lock in. So could somebody tell me how I get ADB again?
By using the area of the arc.
Area sector.
Why about sector?
yeah, the sector.
So the area of sector, that will be OADB minus what?
The area of the triangle, which is AOB.
It will be
Cool, so we need to find the area of the sector. That's not a problem. Remember, the sector is just piece of the whole circle. Do we know that? Yes or no?
Yes, sir.
How do you find the area of a whole circle?
pi r squared too.
Yeah. Did you guys know that?
Yes, sir.
I don't like this quiet thing, you know. I don't like this quiet thing. Earlier,
Hey,
I
hey,
shit.
you want vibes up
Yes,
in
sir.
here.
Yes, sir.
This quiet
We
thing,
gotta
huh?
get some gas.
Yeah, so that's just going to be theta all over 360 multiplied by pi r squared minus the area of triangle AOB, which we found to be 390, and centimeters squared, because it's area. You know what I mean? Yeah.
Yes.
And well, we know that the angle there is 120. So 120 over 360 multiplied by 3.142. And the radius was 30 ends.
Yes, sir. I got 942.6 when I
Remember,
use the area, the sector.
right, so let me verify that. 120 over 360 multiplied by 3.142 multiplied by 30 squared. Yeah, I'll get 900 and essentially 943.
Yes, sir.
Yeah, when you minus out, what are you getting?
I got 553, sir.
So again,
No,
centimeters squared,
no, sir. 553, not 43.
553.
Yes, sir.
I'll get that.
Yes, sir.
yes.
Okay. I feel like so much all is like so confused right now, but like I genuinely think a lot of you all confused. I don't know, it's just not saying
No,
anything.
sir. We just taking it in.
Taking it in.
Yeah, we have
Mm-hmm.
to absorb the information like a sponge.
Now you have to understand the information, like Einstein. Maths is not about absorbing, you know, it's about understanding. Like maths is a one subject. You can't like, you know how you could like read biology and thing? Nah. This is one of these subjects you can't do that for. You have to do. Yeah, I don't understand.
Every time I mention Einstein, I think about the apple falling in your head too.
That was Isaac. No, Ollie, that was Isaac Newton. Oh my
That was
god.
Isaac, boy.
Oh
Matty Einstein.
boy.
No, I mix it up.
It's
Eh,
basically the same thing, though.
No, it's not.
It's basically the same person.
All right. Ollie, if you like, Ollie, all right with A, B, and C.
Yes, sir.
All right, let
Yeah.
me go.
Yes, sir.
The area of the inside surface of the tank, which is in contact with the water.
Sir,
Okay.
I know almost, sir.
So that's AB.
No,
ABD.
no, no,
Oh
no.
wait,
So we just figured out for the last one, which was the
the
shaded triangle.
area.
We just multiply that by the height, and we probably just have to find the area of the cylinder.
Not quite. It's a lot.
No, but
It's
Elliot,
more.
No, the volume, not the area,
No,
volume.
no, no. It's a lot more complicated than I think. What they want you to do. So the area of inside surface. So the area of the inside surface of the tank, which is in contact with the water. So like this part of the tank is in contact with the water. This part of the tank is in contact with the water, and this curved surface over here, that's in contact with the water.
Yes, sir. That is what I was talking about, sir.
Okay. And so what you need to do, or you need to imagine this, like okay, imagine like you were to break it up into its net shape. Okay, guys, if all you unravel this, right? Like okay, imagine you had this shape over here, and you unravel it. What kind of shape that would form?
Half of
Like
the
a
circle,
like
like
a
two
rectangle.
semicircles and a rectangle.
It would
Yeah,
form a rectangle. Yeah,
yeah, because because if you unfold it,
exactly. It form a rectangle. I tell you, these questions were a lot harder than all it take. Right? So you have trying to draw it so they can see what we're talking about.
So would you want to use the app that you initially just unwrap the whole thing, sir?
I don't see how that I could try it. Safari can't open the page because it can't connect to the server. Launch Polypad. Come on, Polypad. I'm not seeing the shape I want.
Yeah,
Trees.
so that.
Yeah, I'm not seeing it. That's dumb. Don't know why they wouldn't have a cone.
No, well, no.
But like this is essentially what
So the app that took you for your shapes, it was really nice to just use that for the semicircle.
hmm?
No, I'm saying that the app that you used for the other shapes before, it would have been nice if they had that shape and we would have seen it in the 3D form.
Yeah. It would have been nice. Now here I want you guys to think, right? Let's see in this shape over here.
yes,
Yes,
sir.
sir.
Imagine this is like a piece of string, right? If you pull this, what's it gonna form?
A
What's-
rectangle. Well, a straight line if you're using a thread, but in this case, it's a rectangle.
But the main thing I want to let you understand is area is just a product of two dimensions. If you could find this dimension and this dimension, you just had to multiply. That's literally it.
Yes, sir.
So everybody in class, can you guys see how this would wrap around? How this would wrap around here?
Yes, sir.
Like, wait, see if I could show you what I'm talking about. Um, mm, as soon as I just see Nikolai staring at me. Oh, then Nikolai just cracked me up. All right, watch this. Oh, let's see this, right?
Yeah,
Oh, let's see in this, right?
Yeah.
When I unfold this, wait, massacre. Right. So I could understand that this is essentially the shape we have, right? Like low key, low key.
Yes, sir.
all right.
Oh, let's see in this, right? And like this would be A and this would be B.
Yes, sir.
When you
Yeah.
unravel this shape, what kind of shape that is?
A rectangle.
Rectangle, sir.
Guys all big up the Chiplo one time.
You know something else?
That too spicy by sir, boy.
No boy. Can't handle
Right?
this. I'll go over this thing one more time, right? One more time. So watch it, right? This is what we have over here, and this is the example I'm presenting over here. Can you guys see the connection?
Yes, sir. I seen the
Okay.
connection.
Like watch. Like I mean it's literally the same thing. Wait, eh? Like I don't know how else I can show it better. I'll see, you know, and like if I and okay, you see in the gray part, right? Ladies, are you seeing the gray part there? Are you seeing what I'm talking about? Oh no. Somebody give me a confirmation or let me know if you understand.
Yes, sir, we understand
Yeah,
you,
I
sir.
understand.
Yes, yes.
And so this is just the gray part, right? And well, as you could see, this paper over here is in contact with the bottle. Are you seeing that, right?
Yes, sir.
Now, if I take this shape, remember this over here, wouldn't this just be the wouldn't this just be the length of the arc? Yeah or no?
Yes, sir.
Yes, sir.
What? Isn't this just the length of the arc? Did we find in our previous question?
Yes, sir.
Yes,
And
sir.
when we unfold it, see that it's straight. So it's gonna be the length of the arc times what dimension? So it's
By the
gonna be
height.
by the 80,
Well,
right?
not.
Well, yeah, it's easy height, it's the height.
Yeah. Okay.
Because if you were to take this and stand it up, you'd see that 80 is the height.
Yes, sir.
There's everybody understand what I'm saying, right? So you see this curved gray thing over here? That's just effectively a rectangle. And one of the dimensions is
Yes.
just going to be the length of the arc.
Yes, sir. You understand?
So I don't know, Math Vibes is the most in-depth in the Caribbean. Most in-depth. So I don't know that. Yeah. So I want to let you understand that this is A, B, and well, this would be D. And well, do we know what this dimension would be? Do you know the length for that
80.
dimension?
80, sir.
Let's see in that, yes or no? And this would be 80. If you can't see, tell me, you know. That's fine. I'll try to explain it. Romano, be honest with me. You understand what the heck going on?
Kinda.
That kinda is song into 100, you know. I kinda hard to
Kinda.
visualize.
I could see like going open to flat and it is a triangle.
A triangle. Nah.
I
Alright, so Romano. Can you imagine this wrapping around the curved surface over here? Like I show you with the what?
Yeah, be back.
I don't know what happened there. But yeah, Romano. This over here, right? Think of this. Think of this as like water, right? Right, Romano? Think of this as water, right?
Right.
And think of this as it wrapping around the water.
Right.
So like you see the gray portion over here?
Yeah.
That's just, you know. And when you unravel it, Romano, what is this? What shape is this?
All right. Rectangle.
Exactly. You sure you understand it, right?
Yeah, I understand.
So watch. Let me show you what I'm talking about. Are you seeing it now?
Yeah.
Yes, sir. So if I get two lines, so
No, no,
where
no, no,
the
no.
kind of chord
No, no, no. Oh, no, no, no. Remember, it's like a shape wrapping around. It's like a piece of paper wrapping around.
Oh, yeah, so with that concept, yeah, okay.
No, no, that is the concept. That is the concept.
No, I understand.
No, it wouldn't be like that. Wouldn't be like that.
Okay.
Remember, Nikolai, like that's okay, Nikolai. That is literally wrapping around. It's like wrapping around.
So, but wait, hold on. So we're not considering the diameter here as well, sir?
Wait, hear what, Nikolai? We already know what this area is, right? And we already know what this area is on this
Yeah.
side. The only thing we
Yes,
really
sir.
have to find is the area of this curved surface here wrapping around the base.
Ah, no, I thought you forgot this part here where the chord. I thought you forgot about the sectors, sir.
No,
You're
no,
not really talking about the line there, sir.
no. We already know what this area is. Remember, we would have calculated that area in on a previous question. That's the area
Yes,
of the sector. Well, not the area
yes,
of the sector, right? That's the area of this. We would have find that by saying area of sector minus triangle AOB.
yes, sir. Well, we just call it.
You know what the internet, boy? I'll give me a second. The internet playing up. Yeah, are you hearing me? Guys, are you hearing me? Guys, anybody hearing me? Anybody?
That's like
Yes, sir.
rotierly
I'm
fast
hearing you,
waves or
sir.
something.
Yeah, are
Yes,
you
sir.
hearing
I'm
me?
hearing you.
Okay.
Yes, sir.
Yeah.
I really hope all you can understand this one. Like,
Yeah,
I,
I
I really
understand.
don't.
It's
I really
just
don't. Wait, wait, let me. I really had to get this. Like, I wouldn't sleep tonight
So
if I
pin
not.
your camera. Pin your camera, sir.
Yeah. All right. Let me look back. Let me look at the concept again, right? Because I know all you're confused. Nikolai, we need to figure out the area um of the surfaces that touching the container, right?
yes,
Yeah.
sir.
Okay.
Yes, sir.
So and Romano, can you guys understand that? Well, this part over here will be touching this end of the container. This part over here will be touching this end of the container. Are you understand what I'm saying so far?
Yes, sir.
Yes, sir.
But what about the piece I would wrap around over here? Watch. Again, if you have this over here, right? Watch. Wait, sir. Wait, give me a second. Right. Do I have a marker? Give me a second. I should have a marker. Give me a second. I'll literally color in on the color in this thing. Right. Hopefully it will make sense for you. I watch this. Can you guys see what happened in here? Yeah or no?
Yes, sir.
Yes, sir.
Romano, what point would this be? This point over here in relation to the diagram.
That'll be A,
Yeah, this could be A, and what this could be?
B.
Right, so the water will be touching over here, but you also and it will be touching it back as well. But you need to consider for the piece that wraps around.
Around. Yeah.
Nicola, you understand?
Yes, sir.
And this dimension over here would just be the outer length for this piece, which was just the length of the arc. And this dimension over here would just be the 80.
Yes, sir.
Don't feel like I could explain that any better. Yeah.
That's how you explained it the best, sir. Well, you explained it the best way. Well, the best you can.
Yeah, the best I can. So let me answer the last question. Part D now. Okay. So, Romano, do you understand that we need to consider the curved part that wraps around the base?
Yes, sir.
So I'd call this A, I'd call this B, and what would this length over here be? Well, how much is that, Romano?
80 centimeters.
Yeah, that'll be 80. Kilani, you sure you understand this?
Yes, so the demonstration was making me understand better, so visualizing it better.
You're sure? You're sure you're not lying to me?
No, I don't.
Okay. So we have that to consider. We also need to consider this over here. And well, we need to consider another one like that. Give me a second. Like a fear I have is like a fear that always like tell me on the sun. Like I'm not just like a real, it's like a big fear, but it's like always just lying to me. Or like I don't know. It's like some issue I have.
What was the area? Excuse me, sir, what was the area that we found that shape to be, sir?
Wait, so I will tell you just now. So we have that, and well, we have another one. So we need to add up all of these. Right, so what did we find this area to be? Does anybody remember these areas?
The 553 centimeters squared.
Yeah. And well, we need to figure out the area of this. So can anybody remind me what the length for AB was? A to B was?
60.
The length of the arc was 62.8. So that's gonna be 62.8 multiplied by
Huh?
what?
The
By
80.
80.
Yeah, because we found out this was 62.8. Yeah, so plug that into a calculator and I'm gonna know all it gets.
I got 5. Oh, well, for the 62.8 times the 80, I got 5,024.
Tell me the final answer.
I got 6,130.
6,130
Yes, sir.
centimeters squared. The 3SF. This is a nice question. Definitely on the trickier side, I would say. So who wants to do another question with me? Any volunteers? So
No,
already
sir.
So I don't mind.
Nicola, you just
I heard that Sky. Sir, I heard that Sky.
I almost hear that too, you know. Sky, you wanna help me with that question? Hey boy, Sky boy. I have a question, right, Ollie? If I wanted to find the area of the curved surface on top, how am I doing that? Somebody tell me. Romano, you tell me. If I wanted to find the area of the curved surface on top, how am I doing that? If you understood the last question, girl, you'll understand this. Let me see if that yes, sir, I understand was true. How would I find the area of the curved surface over here?
Well, you have to know the area of the sector, and then
No, the area of the sector has nothing to do with it. The area of the sector don't have anything to do with it. Nikolai, put on your hand. Let Romano answer the question. Romano, when you unfold that shape, what would it turn to? What would it become?
okay, it will turn into a rectangle.
It will turn into a rectangle, right? You know that one of the dimensions already will be what? What would one of the dimensions be?
1.2 meters.
So all you have to do is find this dimension, which is a length of a. That's the length of a what? What do you call that?
Arc.
Good. So Romano will help me with this question. Yes. Since you want to volunteer, Sky and thing.
Excuse, so one question before you guys continue.
Yeah.
I saw like one of the sentences of the question, they said the semicircular prism. So that means it would have passed through the origin or the center of the circle, right?
Yep. This is half of a circle.
Half of
Right,
the
so
circle.
I believe how I would have solved that.
Wait, Nicola, I'm not asking you, but I'm not asking you, Nicola. Asking Romano. Asking Romano.
No,
They're getting too excited, but you can tell he's my son, you know. You can tell. You can tell.
I was just trying to figure out another way to do it in a sec.
Romano. Here's your question. I'll read.
The diagram below and drawn to scale shows a block of wood in the shape of a semicircular prism. The cross section of the prism has a diameter of 30 centimeters. The length of the prism is 1.2 meters. Calculate, giving your answer to 3 sigma belows. The area in centimeters squared of the cross section.
You know what cross section means?
That is the as
Yeah, here what? Tell me what shape it would be.
cut
What
a
shape?
certain part of the prism, a certain part of the prism, it will be the same shape.
Yes, that's correct. Right.
Yeah.
Now, in the question, it said, is a semicircular prism. So it's safe to assume that this shape over here is a what?
A semicircle.
Good. Actually, do a 24-hour live strictly doing these kind of questions.
Yes.
Yes, sir.
Good, as a semicircle. Now, Romano, we know that a semicircle is just half of a what?
A circle.
So any formula you use to find out any formulas you would use, you would just divide it by 2. That makes sense?
Yeah. Yeah.
So they want me to find the area in centimeters squared of the cross section. I've highlighted the cross section for you. Now the cross section refers to a piece in the shape that when it cuts, you'll get the same shape continuously. So like imagine you have a knife here and it cut. No matter where you cut, you are going to get that semicircular shape. Cool. So Romano, tell me, how would I find the area for this?
Pi r squared divided by 2.
Right. So it's the area of cross section. I could just say CSA, cross sectional area. CSA would be equal to pi r squared all over.
2.
So that'll be 3.14 multiplied by what the radius be?
15.
Aha, I didn't trick you. Does everybody understand why he said 15?
because it's half the diameter.
Good, 15
Yeah.
centimeters. Yeah, multiply that and tell me what you get. The three significant figures. It's an easy question, to be honest.
And 53, sir.
353 centimeters squared. Cool. Romano, part 2 now. They want us to find the volume in centimeter cube of the prism. So Romano, the volume for any prism is the cross-sectional area multiplied by the what? For any prism, cross-sectional area by what? That good thing I call a Romano, you know. Romano, stop smiling, tell me the answer. Be serious. Cross-sectional area by what?
Okay.
Alright, so let me show you a way to visualize this, right? Your textbook. Each page is 2D, right?
Right.
So if you wanted to find the volume, you'd find the area for one of the pages, and maybe you might multiply by the amount of pages you have. Why am I saying that? Because when you stack a bunch of 2D shapes on each other, you create what dimension?
Like three dimension.
Exactly, you create a three-dimensional shape. Cool. So you're stacking a bunch of these shapes repeatedly on top of each other. And what dimension would that create? Which dimension?
Dimension.
No, which dimension that creating? The 30 centimeters, the 1.2, what that creating?
Oh, it creates only 1.2 meters.
Right, so the volume for any prism Romano is cross-sectional area by
Length
height. Right.
or height. Yeah, in this case, height.
Well, it's always height really. It's really always height. Because you could imagine, right? Let me just... Yeah, Romano, you see what I'm talking about? If you put this shape standing
Yeah.
upright, if you put this shape standing upright, wouldn't this be the height?
Yeah.
Cool. So the volume is just going to be the cross-sectional area, which is 353 multiplied by the height. The height is 1.2. I'm going to wait get for that.
$423.6.
Three significant figures. The weight of three significant figures.
So 424.
And centimeter what?
Cube.
Okay, now I have an additional.
Well, it's gonna change the 1.2 into centimeters.
Oh yes, yes, that's a really good point.
Oh
I didn't
yeah.
see that. I
Yeah,
did
because
not.
the 1.2 is meters, not centimeters.
Yeah, I was not going to knock that, you know.
That's a really good point. I didn't even see that. It's a really good point. Yeah, so we'll have to multiply that 1.2 by what? Um,
1,000.
Uh,
100.
100.
Yeah, not 1,000. Remember, 100 centimeters make 1 meter.
1 meter.
So 1 meter would be 100 centimeters. Yeah? No? I'm gonna follow you okay with that.
Which is
The person had said 1,000. I'm gonna if you're okay with that.
Oh, yes, sir. Yes.
I said in centimeter cube.
so it'll be, yeah. So
What
it'll
would it,
be 353 by 120, which is 42,360
now to three
centimeter
significant
cube.
figures, right? To three significant figures. That would be 424
Oh,
0.
yeah, 42400.
Now let me give all a quick question to do by yourself. Part 3. Find the area of the curved surface on top. Yeah, I'm giving you all 2 minutes to answer that. Go. Valentino Bali from Valentino Bali? Valentino Bali POA guy?
Yeah.
Yeah, watch. Man is the goat dog, the ultimate teacher. They got Bali one
Yeah, I
time.
know Bali is.
You know Bali? He the speech POA and thing. Yeah. Well, let me not talk. I'll have a question to do. Kelly, you there?
Yes, sir.
All right, Kelly, let me tell you if we did was correct. And let's correct. Do the multiplication. Yeah, perfect. One thing though, they tell you to round off the question says to round off your answer the three significant figures. So as the one thing I'll tell you to fix. But excellent.
So that the first time I feel I ever get a measurement question correct on my view.
Big up yourself. Progress, man. Progress. Nikolai, again, you had to convert that 1.2 to what? You can't multiply two different lengths in different units. So you had to convert that 1.2 to what?
120.
Exactly. Yeah. All right, so
Receiving the corrections, sir.
I'm waiting for Romano because Romano is the one man I want to see. I want to see Romano get it correct. Because Romano does be telling me he understand. But I just make sure you understand.
So is it correct? No?
Not quite. I don't know how you get a different answer. Put that back into your calculator because I'm again that. I feel like you just want to write six
Okay.
seven, Nikolai. I feel like you just want to write 6 7. That's why I feel. Okay, look what Nikolai go perform. Watch. Let's see Nikolai. Watch. Kelly, you seeing him? I need to say he do.
Yeah, see, I see what mistake I make, sir.
Romano, did you get through or not?
No.
Romano. Let me go back to the last question, right, Romano? How did we figure out, Elmer Romano? How did we figure out the area of the curved surface that was hugging the base of the cylinder? You remember how we found this? You remember how we found that area or no?
I forget already.
Right, so Romano, when you unfold that, what would it be?
Right, it will become a rectangle.
Right. So you already have one dimension, but how are you gonna find this dimension? First of all, what kind
We
of
have to
shape is
find
that's a what? That's a E. What's that?
the arc
That's an arc. Now an arc is just a fraction of what?
of a circle.
Exactly. So Romano, this over here is really the what? It's really a what?
There's an arc.
Yeah, well, this is an arc, but we know that this
For the
is,
the
tell
whole
me,
thing. It's a semicircle.
it's a semicircle. So how would I find this length over here?
Or yeah, to find the circumference of the circle and divided by 2.
Look at know the thing. Do it from one paper and send me the answer. Romano, some do the thing on paper and send it to me. Kelani, I don't think I get an answer from you.
Yes, sir. I fixed my error, sir.
Kelani here. I think Kelani fall asleep. I think Kelani fall asleep enough. Maybe. Very boy killer. Oh, you think Kelani fall asleep, guys?
Probably.
Or Kelani just be talking about vibes and thing and staying up and thing. Fall asleep. Very boy Kelani
So
boy.
is my answer correct?
Let me see. Tell you. Yeah, that. But remember, three significant figures. Three significant figures.
Okay.
Oh, by the way, earlier again, any Wi-Fi problem fixed. Like, I call the people that from Ampli and I tell them about my situation and coming tomorrow, they might fix the Wi-Fi. So no Wi-Fi problems after tomorrow.
So you could be doing live streams and on Zoom at the same time without lagging.
Yes. Romano, I'll wait in it. I have to get an answer from Romano before we leave
Yeah,
tonight.
almost done.
Ooh. In the meantime, though, well, I could probably give Ole some homework because after this question, I gotta call it tonight. Yeah. So, Kaylee, you feel like you have more confidence when it comes to these measurements questions now? Like, low-key not bad, right?
Yeah, some low-key not that bad.
Yeah.
I'm still afraid that when I end the exam, I wouldn't be able to figure out what to do.
Whatever makes sense, do that.
Fun.
If it not making sense, do continue. Yeah. And my best advice for you right now is just practice, practice, practice. Just practice. Okay, Ramona, you get through?
I make a slight mistake that I realized. Oh no.
All right. All these questions so nice. What?
In the meantime,
Nikolai, read this, read this, read this.
construct the full-size drawing of the plane
The plan.
and elevation.
Way
Oh,
boy.
plan.
Plan on elevation and
So
thing.
we're doing technical drawings.
I tell earlier, like maths in the 90s was different. Was different.
So that's not from TD.
That is
Yeah, I
from
was
TD.
about to say that look like a
It's from
So
technical
TD.
that's
drawing
not
question.
from TD.
This from
I'm
TD.
so glad I never picked it.
You would have to, look at this from the top, draw a diagram, and do like a elevation. So you'd have to do something like, yeah, well, way boy.
So my question is for the question that we were just doing, so right? Couldn't I just find the surface area of the whole cylinder and cut it in half? Because they said that the semicircular prism, meaning that it passed through the origin,
Yeah,
and
if you want, you could just
for
find the
the whole,
circumference. you could find the circumference, and well, you could multiply the circumference by 1.2 and divide that by 2.
Yes, sir. And for the volume, we just use the volume of the cylinder and just cut it in half.
Yeah, that's completely legal. Completely legal. Romano, how to get them, boy. How to get them. Alright, so Akira, I see you sent me something there. I see that road cross-sectional area. Well, this has nothing to do with cross-sectional area, eh? This has nothing to do with cross-sectional area. What is cross-sectional area? So, Akira, I want you to imagine. Imagine this is like bread, right? And imagine this is a knife. Imagine you're slicing it like this. And when you slice it, Akira, all the shapes you would get is the exact same shape. That's what it means. That's what cross-sectional area means. This would not be cross-sectional area. That's just this over here is just like a flat shape wrapping around the semicircle.
Yes.
So like that would just be, yeah. So I see in a half. Yeah, that's correct. That's correct. Good job. Yeah. Mano, you getting through? Talk to my Mano.
I'll take any picture now.
All right. If all you want, I'll send on you all of this, or you could try some questions and send it to me. It have topics by have questions by topics. Yeah, like all you think the functions question right now are difficult. Nikolai, watch. Deduce an algebraic expression in terms of x for f to the power 4x, and hence calculate f for 43 show that gf of x is equal to hx. Determine the range of values of h of x such that h of x is more than 1. Show that if h of x is less than 25, then x would be between -2 and 8. Yeah, Nikolai, compare this to the functions questions are getting now.
Yeah, it is easy, but they gave you some information that is very important so that it didn't look hard doing it.
But like these types, okay. Basically, they water down all the exams. They're making the exams a lot simpler now. A lot simpler. Yeah. That's basically what they do.
I'll send you my answer.
Let me see. This is the moment of truth. Yes. But it wouldn't say circumference. You would say, well, I see right circumference is equal to 2 pi r, right? In the next line, you should have say length of arc or something. Or like perimeter of a semicircle or something. Yeah. But yeah, that's good. I'll take that. I'll take that. So I will send you guys this over here, and I'll could try some questions from it. It have lovely questions. Very, very nice questions. My next batch of students, I'll be using this to make sure they work their brains. Yep. So yeah, guys, hopefully have
So
a
before we
blessed.
leave, right?
Yeah, before we
Before we
leave.
leave. When you take off the Wi-Fi, I'd ask everybody if they know what hard roti is.
Hard roti.
I still
Had
don't know what that is.
answered,
What
you
is
never
hard roti?
answered.
Hard
Yes.
roti.
So basically, you make sada roti, you let it cool down for a bit, and then you cut it, put cheese in it, put butter over it, and just put it back on the
Oh
on the
yes,
oven.
that
That
is
makes
real good.
sense.
Wait until
That
it
makes
gets.
sense. Like
That is.
crunchy roti.
But you, by chance, you name it that? Oh, that is like
I feel he named
Yeah,
it.
rename it up.
But that is real good. Yeah,
I just
everybody
call it toast roti. And
everybody had a different name and thing in it. Yeah. Well, guys, I gonna head out there. I have work to do. Hopefully, have a blessed night. Take care, guys. Love and peace.
You too, sir. Bye bye.
Later.
Later.
7